Hello there, this is George from Greenware Services. Most of us are familiar with Outlier in data analytics. Based on my experience of working with over hundreds of analysts, I found many analysts tend to remove too many extreme values. Here I made this video to explain my understanding on how to deal with extreme values. Here list the most common methods to detect the outliers. For one variable, we can use box plot, histogram, or similar distribution of the variables. For two variables, we can do a scatter plot. There are so many resources online explaining how to use these methods, so I will not explain them in detail here. After the extreme values identified using these methods, the question is, are all the extreme values outliers? Extreme values may be caused by a variety of reasons. I simply categorize them as follows. First, data errors. Some of the extreme values may be caused by errors, so those definitely need to be excluded in our analysis. Second, some extreme values may be caused by a business process or phenomenon that is different from what we are studying. Most values need to be excluded too. The last situation is that those extreme values are the true values. They are also related to the business process we are studying. Those values, we definitely cannot simply exclude them. Most probably we have to include them in our final analysis. I'll give you a few examples on how to deal with the extreme values in our data analysis. The first example is forest seedling trees. This histogram illustrates the tree height distribution in a field plot. The x-axis is the tree height. The y-axis is the number of trees of the same tree height. So you can see most trees or seedlings have height less than 3 meters. But there are some trees with height more than 10 meters. Some are even more than 13 meters. So the question is that, are those trees errors? First, we can check from their metadata to see if there are anything explained those big trees in the metadata. If not, then we can do some research on the forest harvest guidelines. In fact, those old trees that were left in the field for purpose during the harvest, they were left in the field to generate new seeds, so they're called seed trees. So, since they are true values, but can we still exclude them in our analysis? Unfortunately, we cannot exclude them in most of our analysis, because those older trees not just provide seeds to a regrowth, they also compete with the seedlings. They compete the resources with the seedlings, such as sunlight, water, and nutrients. So we cannot simply exclude them in our analysis. Of course, this can mix the seedlings and other trees together, make our analysis much more complicated. But we may have no choice. We have to figure out another way to deal with it. Let's move to another example. Emergency calls in a city. This scatter plot illustrates the relationship between local residential population and emergency calls. So the x-axis represents the population, y-axis represents the number of emergency calls. So we can see clearly most of the calls are less than 2,000. Only this one at the top, it has over 7,000 emergency calls. So we check the data in detail to see if it's true values, and we found it represents airport areas. Because they are the airport areas, most are travelers, and the travelers' behavior is quite different from local residents. And our analysis mainly focus on local residents. So even this point is not an error, we can still consider it an outlier because it's travelers. And we can simply exclude them from our analysis. Still using the example of emergency calls. This time we check it in different angle. The scatter plot represents the relationship between the average age and the number of calls per thousand people. From this scatter plot, there are 3 points quite far from others. These 3 points represent areas with exceptional residents. Those residents are senior residents. They have special medical conditions. So they use the emergency services much more frequently than other residents. And there are true values after we check the data. So can we exclude them? No, we cannot, unfortunately, because they are from the residents, and those local residents are our focus topic in our analysis. So we have to include them. Of course, this will increase the difficulty in our analysis. What will be the impact if too many extreme values are excluded in the analysis? Here I only explain the impacts on predictive modeling. First, the coefficient value will be changed. This means the trend line in the model will be changed. Second, R-square is inflated. Since the extreme values are removed, the model itself looks much better, even though it is not true. Another important impact is the uncertainty level reduced. This means the risk is underestimated, which might be critical in risk analysis. Here we give an example to demonstrate the impacts of extreme values. Where did a project on rental properties? Here are 2 scatter plots. They both reflect the relationship between property size and rent, and they use the same dataset. The plot on the left side includes all the data of the dataset, while the plot on the right side excludes some extreme values. So when we compare the 2 plots, we can see the model has changed. The coefficient and intercept are different between the 2 plots, and the R-square at the left side is 0.2, and after some extreme value removed, the R-square increased to 0.3. It's a big increase. Of course, 0.3 is still pretty low. This is because we only use the property size as independent variables. The rent actually are affected by many different factors, so we only use a property size here as a demonstrations. The biggest impact of the extreme values would be the uncertainty level when we do risk analysis. Using the 2 models of the rental properties, we will run a Monte Carlo simulation to estimate the means and standard deviation. So we use a property with a size of 800 square feet, and we run 1000 iterations. The Monte Carlo simulation outputs the mean values and the standard deviation here. So we can see the 2 models output different mean values of the rent. This is because the 2 models have different coefficient values. Actually, the most important is the confidence intervals of the 2 models. The confidence intervals are calculated based on the standard deviation. So here we can see if we exclude the extreme values, the confidence interval can actually match smaller than the confidence interval output by the model, which included the extreme values. So this means the model without extreme value underestimates the risks. Here comes the final question: how do we prevent misidentifying outliers? It is a bit complicated question to answer. There are some general rules we can follow. First, ask the data owners. Check the errors in the data. Try to improve the data quality. Second, ask subject experts. Understand their business process and make a logical analysis for those extreme values. Third, do literature research. Try to understand how other people explain their business process, how they treat their extreme values. Finally, the rule of thumb: we only remove the records that we are fully sure they are outliers or errors. For any records we are not sure if they are outliers or errors, then in general we should include them in our analysis.